Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stolyarev II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization. Greetings, ladies and gentlemen, and welcome to our U.S. Transhumanist Party Virtual Enlightenment Salon of Sunday, February 16th, 2025. Today, we have a fascinating conversation in store for you about personalized longevity consulting and what approaches are possible to extend lifespans and health spans today. Joining us is our panel of U.S. Transhumanist Party officers and members, including our Director of Visual Art, Ramon Garcia, our Director of Scholarship, Dr. Dan Elton, our Director of Publication, Zach Richardson, our member from Texas who leads the Texas Transhumanist Party, Alan Crowley, and our special guest today is Kira Marie Nightingale. She is the founder of Strategic Scientific Innovation Consulting, LLC, or SSIC.LLC. She is an integrative biologist who specializes in personalized longevity consulting, where she helps individuals optimize their health, create tailored strategies, and explore innovative therapies to support longevity and vitality. With over 15 years of experience in biotechnology and regenerative medicine, she is passionate about helping people achieve healthier, longer lives. One of her services is to prepare a personalized longevity strategy document for clients. This document is a comprehensive health roadmap tailored to each person's unique needs and includes supplement plans, diagnostic testing guidance, and actionable strategies to improve vitality and well-being. So welcome, Kira. I'm really pleased that we are able to have you as our guest today. And please tell us more about personalized longevity consulting, the path that led you there, and what insights can be gleaned from it.
Thank you so much, Gennady. I'm very excited to be here. This is going to be a long talk. And then, of course, I want to answer questions afterwards and go further in depth into how we are going to tackle these longevity protocols at a individual level. But to get started, let's go ahead. Yeah. I have a very simple slide deck today because I'm going to do mostly a lot of talking. Hi everyone, I'm Kira Marie Nightingale, and I'm really excited to be here with you. We're going to cover many exciting topics, but first I want to share a bit about my journey and why this field means so much to me. I come from a family of scientists, medical engineers, medical doctors, head nurses, and computer engineers, and now even the young ones are getting into AI algorithms in our family. Thus, growing up, I was surrounded by conversations about engineering and technology, especially because my dad is a doctor of internal medicine who also loves physics on top of it all. And likely due to a combination of nature and nurture, my dad being a doctor really influenced my trajectory in life. One of many of my most favorite memories, in fact, is one with my dad dancing around the living room, my little feet on top of his, as he'd ask me one thing on repeat. He'd ask, "What are you going to be when you grow up?" And he trained me to say, "Not a doctor." So, what are you going to be when you grow up? Not a doctor, I would always reply. So, but for me, the reality was that, apples don't fall far from the tree, and I had a natural inclination and interest in medicine. So in high school, I realized that I loved chemistry and got the chemistry award for my junior year. And when it was time to pick a major in college, I kept thinking, well, what can I be that isn't a doctor? So I chose to focus on biotechnology because I realized that, as the name implies, biotechnology is for those who want to innovate on the future of medicine. Then sometime in my freshman year of college, which was in 2009, I saw a TED Talk that changed my life forever, and it was called The Roadmap to End Aging by Aubrey de Grey. that talk opened my eyes to the vast possibilities of regenerative medicine and the scientific pursuit of not just slowing aging at the cell level, but reversing. And I have to say, it clicked instantly. It made so much sense to me, and I knew this was a direction I had to take, and one of the primary missions that I would dedicate my life to. Then after graduating with my degree in 2012, I eventually connected with the local biohacking community in Austin, Texas, where I had the chance to get more hands-on lab experience and help produce novel gene therapies with a young startup called Circle, based on a novel idea using circular DNA to deliver gene therapies. Later, I supported a company pioneering whole body female rejuvenation stem cell techniques, in particular, that were also beneficial for fertility during a very challenging time after the passing of their CEO, ensuring that their groundbreaking technology survived that tragedy. Then turning to COVID, and that time there was a surplus of jobs, and I was given the opportunity to prove myself in a more traditional lab setting, and I ended up becoming the lab director of a small diagnostics lab, primarily doing QRT PCR tests during that time. And there were many days of operating the entire lab myself with just one other coworker. So I chose a more non-traditional path for my higher education in biotechnology by choosing to get hands-on experience rather than more debt than I could probably pay off in my lifetime, because, and because of that, I contributed to cutting-edge gene therapies, female rejuvenation therapies, and I never stopped learning despite not being in school for another 6+ years. You can always learn and continue to read, scientific papers, and I did exactly that. I read, wrote, and shared science all the time. As many of you might know, my media channel, Radical Science News, and that, grew organically just from sharing scientific information up to 100,000 organically run followers, where we shared, and I shared information from all the fields of science. But anyway, so I never stopped learning, and I took that foundational knowledge, and I that I gained in college, and continued with that. And I let my love of science and cell biology take me down any rabbit hole, because once you learn how to read scientific papers with a bunch of stuff that looks like jargon, you never lose that skill. You only get better at it over time. So with that very long introduction over, I'm excited to share what I've learned and where I see the future of medicine going based on what I know right now in early 2025. I think it's important to first start with the early days of medicine. So, in the early days of medicine, much of the practice was based more on guesswork and trial and error rather than on scientific principles. So early practitioners, they would catalog symptoms and experiment with herbal remedies, and often with mixed results. And it wasn't until Hippocrates introduced the revolutionary idea that disease had natural causes rather than being punishments from the gods, that medicine began to move forward towards evidence-based practice. So, compared to medicine just 150 years ago, modern medicine is deeply connected to the principles of transhumanism. The idea and philosophical approach that we can and should use technology to enhance human capabilities and extend lifespans. And each major advancement, from antibiotics to organ transplants to gene therapies, is a step towards transcending biological limitations. So, transhumanism is very baked into modern medicine itself, in my opinion. But anyway, let's walk through some key milestones to illustrate the relationship between medical innovation and increased lifespan. So let's go to the next slide. So with the Neolithic Revolution, it was marked by the invention of agriculture, which allowed human populations to settle and grow food. However, living in close quarters with domesticated animals also introduced new infectious diseases, and life expectancy averaged around 20 to 33 years of age. Then in ancient history, Greek physicians like Hippocrates and Galen laid the foundation for scientific medicine, while Roman engineers built aqueducts and sewage systems to improve public health and sanitation, which is very essential. And then life expectancy still remained pretty low, averaging from around 25 years, although some who survived childhood could maybe live, into their 50s and 60s. And then in the Middle Ages, medical knowledge stagnated as religious beliefs often overshadowed scientific inquiry, and luckily hospitals became more common, and translations of Greek and Arabic texts preserved critical medical knowledge, so that was important. And then the average lifespan, even still though, hovered around, the late 20s, so, maybe 27 to 29 or somewhere around there, but before your 30s. And then the early modern period was the invention of the microscope, and that opened new frontiers in the understanding of human biology, while societal factors like poor sanitation still limited life expectancy to around 30 years. And scientific inquiry laid the groundwork for future breakthroughs, at least at that time, but still almost no change. And then during the Industrial Revolution, there was urbanization brought new public health challenges, but also new solutions. So like modern sewer systems and soap production. And then by 1900, life expectancy in Western Europe had climbed to 35 to 40 years. I mean, geez, sewage systems and soap. So anyway, so then for our next slide, do you guys see the next slide?
Yes, we do.
Okay, just a second. It's all good. Okay, so the late 1900s and early 20th century, germ theory transformed medicine and medical practice. Innovations like antiseptics, anesthesia, vaccines, and antibiotics drastically reduced mortality rates, pushing life expectancy past 50 in many countries. And then, of course, the post-World War II era, breakthroughs in medicine through medical imagery, surgical techniques, and widespread vaccination campaigns brought life expectancy to around 70 by the mid-20th century. So we really have a very big leap there. And then in the late 20th and early 21st century to present, biotechnology has taken center stage with the completion of the Human Genome Project in 2003. Stem cell therapies, exosome treatments, 3D bioprinting, and targeted cancer therapies have all emerged as powerful tools to fight disease. And today, the life expectancy in many developed nations exceeds 80 years old. So as we see, it wasn't until well after the invention of the microscope in 1590, followed by roughly 271 years later by the articulation of germ theory around 1861, that the groundwork was laid for modern infectious disease prevention. Another 20 years passed before it was broadly accepted, though in the early 1880s, signified by Louis Pasteur's very dramatic 1881 anthrax vaccine demonstration at a farm, where he vaccinated half of a group of sheep and left the other half unvaccinated, then later exposed them to the Bacillus anthracus, and vaccinated animals survived while the unvaccinated ones died, offering powerful public proof is what that did, and it targeting a specific microbe, showing that a specific microbe could effectively prevent disease. And this breakthrough helped cement germ theory in both scientific and public opinion, because at the time it still wasn't fully cemented. It paved the way for improved sanitation protocols and other vaccines, and ultimately raised human lifespans to the 80 plus years that we see today. So germ theory at its core wasn't just a discovery, but a new way of seeing the world. And by understanding that microorganisms cause disease, medicine gained access to the previously unseen world, which is, this conceptual breakthrough led to antibiotics and all these different things and more, and illustrated how, in my opinion, how paradigm shifts often start with reframing our understanding of a problem. So innovation isn't only about discovering new tools, it's about tackling problems strategically and systematically once we see them in a new light. I think that's very important. We'll get more into that later. So I understand that, to many out there, the discussion about vaccines can sometimes feel divisive, but and that people hold strong personal views or reservations, but regardless of belief, one of the most important developments in recent modern medicine has been the rise of mRNA, messenger RNA vaccine technology, which may be applied not only to combating viral infections, but also personalized cancer treatments, certain autoimmune conditions, and more. So, we can't really talk about modern medicine without, in a way, talking about mRNA vaccines. So let's talk about how it works. So within our cells, DNA is transcribed into mRNA in the nucleus. The mRNA then travels to ribosomes, the cell's protein assembly machines, which read the genetic instructions and link amino acids together to form specific proteins. An mRNA vaccine leverages this natural process by delivering custom mRNA that codes for a harmless fragment of a virus or another disease-specific protein. So that could be for cancer or other things. So our cells then produce this protein temporarily, and the immune system learns to recognize and neutralize it. Because new mRNA sequences can be designed rapidly once scientists have the necessary genetic data, these vaccines can be developed and scaled much faster than traditional ones that rely on growing whole viruses. So before mRNA technology, vaccine development was slow and resource intensive, and we'd grow viruses in chicken eggs or bioreactors. I'm very familiar with bioreactors, so it's a very touchy process and it's not easy. Bioreactors is a very inefficient, very difficult way to produce something, but it's possible. It's just, it's very cumbersome. So but anyway, so they would grow them, in chicken eggs or bioreactors, and either weaken them or neutralize them completely, and then use them to train the immune system. But mRNA technology skips those steps entirely. Instead of delivering a virus, we give the body genetic instructions to produce a harmless protein. So such speed led to streamlined regulatory measures during the pandemic, as we all saw, when governments and health agencies adopted emergency authorizations and expedited trials to ensure that these innovations reach the public as fast as possible, showing that progress can indeed happen at rapid rates if we see the need. So I, of course, do not condone forcing anyone to take something if they do not want to. I believe this was a major mistake by government leaders. For example, if I were to put a regenerative organic food in front of someone, no matter how beneficial and nourishing it might be, forcing them to eat that would still be wrong. So, I share these insights on mRNA technology simply because it represents a remarkable stride in modern medicine, one that could transform not only how we manage outbreaks, but also how we tackle various diseases, including cancer, through highly targeted personalized therapies. So I've had conversations with fellow researchers and innovators who are working on groundbreaking projects in medicine who say that mRNA technology represents a major leap in development. And one group was even working on mRNA solution to cut the mortality incidence after major heart attacks by around 50% by increasing mitochondrial regeneration through mRNA's efficient information delivery system. So its adaptability means we can potentially create vaccines for historically elusive viruses like HIV, or even develop personalized cancer treatments. And this is crucial because we've largely mastered bacterial infections, except for super strains and things. But we've largely mastered many bacterial infections, and that's a topic that's a whole other conversation topic I'd love to talk about sometime as well. But anyway, viruses and cancer remain a significant threat due to their rapid mutation rates and reliance on hijacking host cells or getting around normal mechanisms for survival. So anyway, when you look at where we are today, you see, many older adults living into their 90s, or, in edge cases, people live to 120, which is quite astonishing. And it's a number that's that 120 is, as many of you probably know, but maybe not everybody listening, is it's a number often associated with the Hayflick limit, which is the theoretical maximum number of cell divisions before growth stops. However, the oldest verified individual, still reached 122. Scientists also have realized that, aging isn't driven by, telomere shortening alone, but it's shaped by multiple factors. In the meantime, nobody really wants to be, 150 and feel like 150. So our next area of focus, which to me is sorry, I meant to say that, the fact that somebody was able to live to 120 or 122, I mean, this shows that we've reached kind of our current limit, right? And when it comes to lifespan, and that there's a whole other level that basically needs to be unlocked. We have a barrier right there at the Hayflick limit. And so that's why, of course, we talk about health span as well, which I'll get more into. But in the meantime, since no one wants to be 150 and feel 150, our area of focus is health span. So the number of years spent in a healthy, functional, and relatively pain-free state. So this concept leads back to Aubrey de Grey's talk, and one of the concepts that he pioneered, which is a longevity escape velocity, which is referring to the point at which we can extend healthy lifespan faster than we age. So in other words, if we can develop treatments that add more than 1 year of healthy life for every year that passes, we could theoretically reach a kind of indefinite lifespan. So just to reiterate that, if we can develop treatments that add more than 1 year of healthy lifespan for every year that passes, then we can reach an indefinite lifespan. So, but Aubrey de Grey, he even suggested that the first person to live to 200 may already be alive. So while that's a bold claim, it's based on the idea that medical advancements can follow the exponential growth of computing power. So the real question then to me isn't if we can extend human lifespan and health span, but whether we can overcome the societal institutional barriers that slow down research and innovation in this domain. So that's why I believe in the potential of specialized zones like ZEDES, or zones for employment and economic development, prosperity zones, or even entirely new types of innovation zones, particularly medical innovation zones that are essentially real estate developments cleared for cutting edge research. One example is, as many of you would probably know, is Prospero, which is a ZEDE in Honduras, which aims to foster foreign investment and innovation, though it's faced a lot of challenges and, legal and public acceptance challenges and more, but by offering scientists a place to collaborate in person, free from the bureaucratic inertia that often stifles progress, these zones could serve as modern freedom zones for research, much like Silicon Valley did for computing. And, although Silicon Valley was never a formal special economic zone, it effectively operated as a freedom zone for tech by combining kind of a risk-tolerant culture, minimal bureaucratic barriers, abundant, venture capital, and close ties to academic research at institutions like Stanford. And, this unique mix allowed computing and software to advance far more rapidly there than in other regions. And the parallels are, instructive. If a region can similarly cultivate these conditions for biomedicine or biotech, it could accelerate breakthroughs in healthcare the way that Silicon Valley did for computing. And I think that's really where we're heading next. But anyway, so while creating large-scale research hubs may still lie in the future, the principle pretty much remains clear, is that we must develop flexible, collaborative environments that encourage rapid experimentation, iteration, and discovery, especially in healthcare. In the meantime, we should rethink our approach to medical regulation. Although big government policies are often well-intentioned, they can slow down the deployment of life-saving treatments, and by adapting more adaptive regulatory frameworks akin to the emergency pathways, used for vaccine developments, we could save countless lives today while laying the foundation for even greater advancements for tomorrow. If we, for instance, if we embrace the same mindset shifts that once brought us germ theory, vaccines, and antibiotics, there's no reason that we can't achieve similarly transformative breakthroughs in longevity and health span. Of course, that will require broad support, and given global mortality rates, it's clear that tackling cancer and heart disease should remain among our highest priorities. So, as in his TED Talk, Aubrey de Grey, he did lay out what he calls the 7 deadly sins of aging, the primary forms of biological damage that accumulate in our bodies over time, and these range from mitochondrial mutations, genetic mutations, intracellular junk, to extracellular junk, and depletion of stem cells, and so on. But de Grey's core arguments is that aging is not an unchangeable fact of life, but rather a cumulative biological process, and that we can learn to slow, stop, or even reverse by developing therapies to repair such damage. So today we've already seen promising advances towards addressing the root cause of aging, senolytics drugs, which can be obtained over the counter or by prescription, and they're designed to clear out senescent cells or zombie cells that no longer divide yet linger in the tissues, contributing to inflammation and organ damage. And then meanwhile, gene therapies such as those that I helped develop and grow it, like I said, manufacture in the early part of my career, show potential for upregulating protective genes and even extending telomeres, the protective caps on your chromosomes. Each time a cell divides, you guys probably know some of this, but each time a cell divides, its telomeres shorten, eventually reaching a critical length that stops further division. And this cellular countdown clock is closely tied to aging and many age-related diseases. But we've begun to move away from merely treating symptoms of aging and towards targeting its underlying mechanisms. And this fundamental shift from reactive medicine to preventative medicine, and then even going beyond, preventative to like what I want to do for my clients, what I'm already starting to do for my clients, is basically going from preventative to optimization of their health at the cellular level through various methods and techniques and principles, and then going into regenerative medicine. So taking it, from optimization to repair and regeneration. I mean, the possibilities get really, really endless at that point, almost. But of course, certain breakthroughs have to happen first, and we'll talk about that. But anyway, this kind of transition in medicine, where we're going from those stages, is really exciting. So medicine is, not just about curing disease, but optimizing and so on now. So Aubrey de Grey and others have really done a remarkable job opening the world's eyes to the possibility of solving aging. But my personal goal is to help lay a foundation of simple, universal principles that clarify how we might solve aging, and how research and the broader public can apply these principles in longevity protocols and therapies themselves, as well as certain groups who are trying to help solve aging. So anyway, despite these strides, especially in our growing, and I'll talk more about that soon, but despite many strides, especially in our growing ability to target viruses, we're still in the early stages of many of this. And at the core, aging is really a slow, systematic breakdown of the cellular machinery that keeps us alive. And what fascinates me is that living organisms are the only known entities that actively fight entropy. If you guys are familiar with the concept in physics of entropy, that everything eventually breaks down and reaches maximum complexity, and just everything basically is subject to degradation. But our bodies, like, we are not like cars. We actually lack any inherent, or not we, but because cars inherently lack any inherent means of self-repair. But humans do repair themselves, and some creatures do it far better, achieving lifespans much longer than ours. For instance, the Greenland shark, which has been documented to live hundreds of years, and the immortal jellyfish, which can reverse to its earlier stage of life, a polyp, effectively back to a polyp, which is a tiny little jellyfish, effectively resetting its biological clock by studying these organisms, we gain insights into repair mechanisms and regenerative strategies that can inform human longevity research. So this is why, to me, nanotechnology, the engineering of materials at the molecular scale is so crucial. But in essence, drugs are already forms of nanotech. They're precisely engineering molecules that interact with our proteins and DNA and cellular structures in targeted ways. And by refining these molecular tools, we can potentially fix or replace damaged components within our cells and tissues. And I'm just showing here on the slide deck this is a circular DNA. This is what you typically have in your mitochondria. So your mitochondrial DNA is circular. It's just kind of concept to show, and then also to show here in the slides, like, this is an example of just the biomechanical and electrical process that happens in our cells, all the time, through ATP synthase, or synthesis, and here is ATP synthase, which is, this is a machine right here. It has a turbine. Our bodies are already nanotechnology, that we're already self-repairing machines. I think it's important to show this to the broader audience here. The complicated movements and connections here of this biomechanical machine that's ATP synthase. This is the molecule that helps produce ATP through a ion, or through a not ion, but through a proton hydrogen gradient in the cells already, in the mitochondria in particular, and it's extremely complex. This is a graphic actually I made on this process myself. I made this graphic and drew these and stuff on my iPad. But anyway, proud of that. But this is oxidative phosphorylation itself, and it's got electrical components. It's got protons, oxygens, electrons, water, and also it's basically a manufacturing line. This is a little manufacturing plant for energy, and so this is why I'm trying to really help people see and understand that we are already nanotech, basically, and that also the drugs are basically nanotech as well. So, and we'll get more into that here in just a second. So, let's see. So, yeah, so drugs are already forms of nanotech, and they're precisely engineered molecules that interact with our proteins, DNA, and cellular structures in targeted ways. So by refining these molecular tools, we can potentially fix or replace damaged components within our cells and tissues. And I hope to, in another talk, go in depth on what are bioidentical molecules versus analog molecules. But this talk's already really long, so we got to do that in another talk. But that is a super important topic for understanding supplements, for understanding the future of drugs. And you got to make sure to tune in for that one, whether that be on my YouTube or here again or somewhere else, because that's a super critical one to go into. So telomere extension, let's get back into that. So my conversations with Dr. Bill Andrews, who pioneered telomere extending gene therapies, further highlighted this potential. So telomeres shorten with each cell division, and telomerase, the enzyme that rebuilds telomeres, could slow or reverse this process. While gene therapy can introduce or enhance telomerase in our cells, such treatments remain complex and expensive. So Dr. Andrews argued that small molecule drugs capable of activating telomeres might be more scalable and cost effective. And if these drugs are successful, they could offer a straightforward population-wide means to slow, stop, or even reverse telomere shortening, which, again, to remind my general audience here that isn't familiar with this topic, your telomeres are what dictate your Hayflick limit, which is, again, the number of times that your cells can replicate and divide, which is what creates that roughly 120-year lifespan limit. So all of this ties back to Aubrey de Grey's concept of longevity escape velocity, is if medical science can extend healthy lifespan by more than 1 year for every year that passes, we'd effectively outpace aging. So over time, exponential progress in these therapies could push us into the realm of indefinite lifespans. And de Grey even suggests that the first person to live was to 200 has already been born. I personally think that if the following, happens correctly, then and we can expedite processes, then there's a lot that we can be done. So that's the takeaway, is that in other words, scientific innovation, it requires freedom. It requires freedom to experiment, to iterate, and question established norms. And the pandemic demonstrated that by streamlining regulatory pathways, we can go from concept to distribution in under a year. And we did that with mRNA vaccines for that specific disease, but we didn't lower necessarily I personally feel like we didn't lower safety standards. We just sped up the approval process, and in doing so, saved millions of lives. So imagine applying that same agility to longevity research with innovation zones like ZEDES, or places more similar to Silicon Valley, but like in a medical sense, and with regulatory approvals and things, and or reduced regulation, one of the two. And scientists could work unimpeded and by outdated regulations, in my opinion. And they could be hubs for breakthroughs. And anyway, I can go on that for a long time too, because that's also something I consult in right now, is sustainable developments. But anyway, of course, creating these zones in the United States or elsewhere would require policy shifts and broad public support. Again, in the meanwhile, if we just this is very important. I think if we rethink how we approach innovation, big government regulations, and everything, like basically we could, create something that is has less inertia. And ultimately, if we seize the opportunities in senolytics, gene therapies, telomerase activation, and drug discovery, nanotechnology, we can treat the symptoms of aging, and not just treat, but but to also resolve the root causes. And so now that Aubrey de Grey and other pioneers have laid the groundwork for understanding the mechanisms of aging, I'd like to propose additional principles that build on and complement their insights. Specifically, I've developed a methodology called Regenerate. It just happened to spell that, or like basically be like a regenerate, spelled R for regenerate. I don't know. It was totally coincidental, but it worked out. So, but this kind of just foundational principles, it's very simple, really. But I think if we applied these, and I think many scientists are already applying this, by the way, they're just not calling it this. But I think this is a really good for my clients and for you and for anybody else. If you also follow these principles, that can definitely help you improve your protocols, your personal protocols, and more, or even your regenerative protocols if you are, already, acting on those in regenerative medicine terms. But here's the breakdown: one is remove. So the first step is to remove harmful or senescent cells, or zombie cells that have stopped dividing yet linger in the body, secreting inflammatory signals. And then clearing these cells basically can help reduce chronic inflammation and restore healthier tissue function because they're kind of gunking up the system, right? And then 2 is repair. So next we repair any remaining cells by addressing damage to DNA, mitochondria, and other cellular structures. This could involve interventions like gene editing, autophagy, enhancement, and other regenerative therapies that can restore cells to a more youthful state. And then replace. So when the cells are too damaged to be salvaged, the solution is to basically replace them, often through stem cell therapies or emerging techniques that generate new healthy tissue, growth factors, etc. So these steps ensure that dysfunctional cells don't undermine, overall organ function. And then express, which is the 4th component, which is to optimize gene expression. So that's what we call it, express. And then you would do that by improving the epigenetic and methylation patterns that regulate how our genes are turned on or off, which we can encourage cells to function as if they were younger, basically, because, that's a whole topic in itself. But basically, you're optimizing the function of your cells through improving the optimization of your epigenome. And then, so this could be techniques that are more like epigenetic reprogramming, nutraceuticals, targeting methylation, and lifestyle factors, of course, that would help stabilize beneficial gene expression profiles. And then extend, finally, we will address telomere attrition. So telomeres, whose the protective caps that are at the end of our chromosomes, shorten with each cell division. And I repeat things so that if you're new to something, hopefully it sets in, just so you know. And so strategies would be to extend your telomeres here, whether that be through telomerase activating drugs or gene therapies, which can preserve a cell's capacity to replicate and help stave off senescence that arises from critically shortened telomeres. So it kind of goes full circle in that way, right? Because it's the telomeres getting older creates senescence, and so telomere extension is a huge factor in this. But of course, we want to remove any really bad dysfunctional cells first before we extend telomeres potentially. Ideally, right, to prevent any cancer, but also, extending the telomeres is, a lot of people were worried that, extending telomeres was going to cause cancer, but actually, overall, extending telomeres, what you have when you have longer encapsulated cells, you have more genomic stability. So it makes sense that, having, yes, ideally you want to take some senolytics before you were to take a telomere extending drug or whatever. But you're going to basically be creating a more stable genetic environment anyway once you do that. So I really feel like, telomeres are actually, extending telomeres is cancer protective, based on that, that logic there. And to me, that logic, it makes a lot of sense. So anyway, taken together, the regenerate, kind of acronym here provides this cohesive framework for tackling aging as a multifaceted systemic process rather than just treating individual symptoms. And by focusing on removal, repair, and replacement of faulty cells, refining epigenetic expression, extending telomeres, we can potentially slow, halt, or even reverse various aspects of the aging process. And over time, I believe, all of them with these principles, just following these principles, and there will be things that you'll have to do at each step, and there will be things you'll have to do in between each of those steps. But, basically these steps I believe are foundational. And, I welcome other scientists and people in the longevity community to, reiterate these, simple ways of explaining how we could tackle aging using my acronyms. Acronym is fine. Of course, I like credit, but it's fine if you want to use them and explain, like, in this very simple way how we can tackle aging to the general population, because that's very important. Like a lot of people, even very smart people, right now don't think it's possible to reverse aging, and that they think it may not ever be possible, or maybe they think that we shouldn't, but regardless of what you think you shouldn't or whatever, this is medical progress is, and technological progress is technological progress, and it's inevitable for the most part. Now, it can definitely be slowed down, it can be hampered, it can be sped up, and that is going to be through public education, and and people getting on board, both in the public and the private sector. So, we have to get, everybody is our friend in this situation, governments, and I know you guys know, but, just reiterating, like, governments and helping the public understand these different things, the progress of medicine as a whole, and germ theory, all that stuff is essential for people to get on board with, understand, have less fear about, have more understanding, have more comprehension, because this stuff isn't necessarily easy, and to understand, and it has to be learned over and over again, and basically, one thing I also want to say is that I really think that the question of should we solve aging, I think one of the things that we need to look at, and this is why I've highlighted so much here in the progress of medicine here, is that we have already solved like lifespan in a way, to a degree, and up to the 120 limit, we've solved lifespan. Now it's just about solving health span, and then getting, and by solving health span and looking at our telomeres, we're going to break that theoretical limit of 120 years old. So by solving health span, we'll be likely solving for aging itself, because nobody, we all like that now we have the potential to live to 100 years old, but nobody wants to feel 100. So I think that just really needs to set in and really sink in with people, and hopefully I've described that well. But yeah, we're already there now. We just got to solve the slow degradation and process of aging, and now hopefully, like, death will be something that's coincidental, especially once we solve cancer, and it could be, through targeted mRNA technologies, it could be through other targeted immunotherapies, but it'll be something like that. It'll be something very targeted, and safe, where it's just like a transfer of information. And the next thing is regulatory hurdles. So once we get everybody having this understanding, then it's regulatory hurdles is the next thing. And I think Liz Parrish has a really interesting white paper on that, which I'm sure you guys in this channel have talked about. But also regenerative developments, that's the other path as well. So I know that Gennady had some questions for me, and here's all my LinkedIn, and just made it really simple. I've got a lot of different things, but I think these are the essential ones right here, and I'm open for your questions, Gennady.
Yes, thank you very much, Kira, for a most excellent presentation, and I really appreciate the overview that you provided of the progress of medical science from really prehistory to our time, as well as what has been achieved and what remains to be achieved. And my first question is in terms of the individual implications of this. You mentioned that right now there seems to be this hard upper limit on lifespan of around 120 years. Jean Calment, of course, lived to be 122. The oldest living male, Jiro Kimura, unfortunately only lived to be 116. So we males still have a way to go to even reach 120. But I'm curious with regard to everything that's available today in terms of healthy living, in terms of accessing the cutting edge of medical practices or opportunities as they currently exist. By how much is it possible for most people to lengthen their lifespans? Let's say if a person does nothing except perhaps avoid taking careless risks, they'll have some number of years they'll live to, maybe the low 80s for many people in today's society. How much further is it possible to push that if a person does everything right by today's standards?
I think what's critical there is if you follow these principles that I've outlined, then your potential to increase your potential lifespan is much higher. But you have to follow these principles of remove, repair, replace, express, extend, and whether that be through, because you can somewhat tackle those through diet, lifestyle, exercise, and supplements. Like tailored supplement plans is something that I help provide as one of my services. Um, but basically, you can very much tailor a supplement plan that follows those principles outside of just a healthy lifestyle. And of course, there's no longitudinal studies on if you follow these principles, will that happen? But I really believe that, since I've been studying aging for so long, now that these principles will help be a guideline for anybody who wants to, they're like, I want to live to ideally 90 or more, outside of the potential of cancer, and, stroke and heart attacks. I want to live to, maybe like 80, 90, if you're really lucky, but more like 70, late 70s to 80s, but very, very healthily with less pain. Not talking about physical therapy and things like that, but those would be included. But, if you follow that protocol, I really think that could greatly extend your health span. And then also something I didn't get to talk about much, but I'd love to talk about another time is to talk about menopause for women and andropause for men, which I think is very crucial, and bioidentical hormone replacement therapy, and how hormones are a fundamental part of the process of aging, or the not process of aging, but the degradation that people experience, like the thinning of hair for both men and women, and all sorts of downstream effects. Without hormonal homeostasis and optimization, you're I think a lot of the optimization of hormones in general could greatly increase health span. And I don't think we've seen any longitudinal studies on that yet either, because it's so relatively new.
Kira, I got a question. With your principles, would you say they're best pursued necessarily sequentially? For example, say remove and then repair, or can you pursue some of them simultaneously? And if they're necessarily sequential, why is it that you chose the order you did? Thanks.
Yeah, no problem. Thanks, Zach. That's a great question. So I think that they need to be followed first sequentially and then all at once. So if you follow them, it's important to follow the first one, especially remove, because we are trying to avoid oncogenesis, which is the formation of cancer. We do not want cancer cells. The best way to avoid that is to remove cells that are not functioning properly through senolytics. And there are, over-the-counter senolytic medications, but there's also, or supplements, but then there's also ones that are prescription, that are not over-the-counter. And this actually gets into drug advancements when it comes to like AI and finding bioidentical versions of drugs or the right molecule that can systematically go in and ensure the death of bad cells. And senolytics itself could help lead to cancer treatments as well. If we really focus on that in medicine, we take it seriously, we can also simultaneously help solve for probably many types of cancers through senolytic drugs itself. And I'm sure that already there are senolytic drugs being deployed, but they're just maybe not like commonly known by that in cancer treatments and chemo treatments already, not radiation treatments. And I'm just saying that for the general public because chemo and radiation are not the same thing. Chemo means chemical therapy, which means it's a chemical way to tackle cancer. So senolytics and the first step are essential, but then after you get that process going, you can do it all simultaneously. But first, make sure you remove before you potentially repair cells that are, already damaged to a point they shouldn't be repaired, but they should be removed.
It kind of goes back to what you were saying about the ZEDEs too, because I remember with the robust mouse rejuvenation studies, I think it was, they showed that dasatinib and quercetin together was supposed to be a pretty potent senolytic, but of course you can really only get quercetin on the consumer market. So it'd be kind of nice if you knew the science and trusted whoever was administering the therapy to be able to go somewhere and sign a piece of paper and say, yeah, give me the top tier senolytics.
So I'll correct
right,
that
which is the regulatory.
Mm-hmm. With regard to the robust mouse rejuvenation study in particular, the one that's nearing conclusion, it did not test dasatinib or quercetin. It tested galactose conjugated navitoclax as a senolytic, and that one actually didn't seem to have a significant impact in lengthening the lifespans of the mice relative to the control groups. And the results are still being analyzed, but it seems that the senolytic had some toxic side effects that may have overpowered whatever benefits it could have produced. Yes. So I did want to ask also in regard to what some of the most impactful actions for individuals would be. Do those actions generally consist of avoiding particularly bad habits or cultivating affirmatively positive habits? So avoiding bad habits would be like not smoking, not drinking alcohol, not taking reckless risks, not skydiving or engaging in drag racing on the streets, that kind of behavior, not taking recreational drugs. Whereas cultivating positive habits would be something like optimizing one's diet beyond the average person's diet. The average person's diet who does take some concern about their food or their health, or doing a lot of exercise, for instance, or doing specialized therapies, taking supplements, taking certain medications. Which approaches do you think are most impactful for, let's say, the majority of ordinary people today?
I think that's a great question. I think for for the ordinary person that, of course, I feel like we all know that the answer is both, but you're saying specifically, like, if, you only have one or the other, then for me, I think avoiding bad habits in particular, and there's a lot to avoid these days. And the reason I say bad habits is because the risk of cancer is unfortunately just and heart disease. So not understanding cholesterol, and there's so much misinformation right now about cholesterol and fats that it's mind-blowing, and nutrition right now. It's everywhere. But if you can really take seriously the risk of cancer by avoiding contaminants and pesticides, heavy metals, etc., you're eliminating a you're already having to do a ton of research with that alone. And I think the normal person, if they're not going to take supplements, they're not going to do any of the extra stuff, they at least need to have the energy for learning what to avoid. And it's not fun. You're going to be reading about cancer all the time. You know, it's going to make you feel it's going to make you feel bad just learning about it. Okay, you're going to be like, "Oh no, I've been eating and drinking this like my entire life." And you know, it's going to be some hard realities that people are going to have to face, you know, like with pesticides and endocrine disruptors and, you know, the cancer causing, you know, lots of other things. And I think if you're just if you're like, there's no way, there's too much information, I can't go through all these supplements, I don't even want to use AI to try and help me at all, like, I just at minimum avoid bad stuff. Download like apps that will help you determine, you know, what if you know what ingredients are in whatever food or product that it is that you're eating, and look at your water quality at home. How do you get the best, you know, reverse osmosis and remineralization system at home, because you know you're mostly water, and really take seriously your, you know, regenerative and organic foods. And if you can avoid the bad habits of low sleep and terrible food and contaminated food, and contaminated water and microplastics, if you can do those things, you're at least a lot better off. You're probably going to be less likely to get cancer. You're going to be living at least to what the average life expectancy should be for a human who lives with access to modern medicine. And that's the problem right now, is that our lifespans are actually going slightly backwards due to contaminants and microplastics, etc. right now. So if you want to maintain what we've already accomplished, you have to learn that stuff. There's no getting around it, in my opinion.
Very interesting. And yes, the risk of cancer is a scary one, because it could, for some people at least, shorten their lifespans to well below the conventional life expectancy. And this is why, even for a fairly risk-averse person, there is not even a guarantee right now of getting to the high 70s, which is the current life expectancy in the United States and much of the Western world. So indeed, avoiding the stimuli of cancer-causing agents would be important. And it's interesting that you focused on contaminants and microplastics in your reply, more so than, say, smoking or drinking alcohol. It was interesting too. I recently lost my grandfather, who lived to be 91, and he lived for most of his life in the former Soviet Union. I can't say that he was a paragon of optimal health, because he did have several comorbidities by his 80s, and he's even a skin cancer survivor from his 60s. But he did have essentially the nutrition of somebody from the mid 20th century, let's just say. And he probably did not get a lot of the substances that are in the food that's widespread in the Western world right now. So he had a different diet. And I wonder to what extent that contributed versus genetics, because his mother was long-lived as well. So there are a lot of, let's say, multivariate considerations there, which makes it a bit difficult. But I wonder if somebody were to approach you and say, well, I would like your services with personalized longevity consulting, how would you go about essentially interacting with that individual, gathering information from them? What would you want to know, like their own health habits, their family history, their test results, and what would you do with that information?
Yes, thank you. And I make condolences for your grandfather. It's very tragic lose anybody. So yeah, so with my clients, the way I tackle it is, very systematically, similar to, the system that I used there. But I also will, look at, I'm HIPAA compliant, so any data that they can give that is useful, depending on what it is that they are wanting. Of course, I can gather and I can look through and I can analyze and. Basically, we're doing that whole process where we're trying to optimize their health. Like, whereas they might go get a hormone panel today, and they're like, "Oh, you're, for a certain aged woman or man, like your hormones are fine." But to me, I would look at those hormones and I would say, "No, they're not fine. They are well below what the healthier version of you when you were younger would have had, and we need to get those to a higher or more optimal levels." And so I would be creating basically tailored roadmaps. It's very individual to what the person wants, but basically we would be looking at, supplements first is the first level because that's the most affordable, right? Outside of lifestyle, like, so they have a pretty relatively good lifestyle. They sleep really well, right now, or they sleep decently. We would optimize that. But, if they exercise a lot, or exercise a good amount, we would optimize that, but that's good, right? And then if how their diet is, we would look at, optimizing that, of course. But if those three things are mostly pretty good, then the next level is supplements. And the next level after that, there's basically supplements, and that the supplement level can go very many levels deep. And in terms of tackling different individual problems, and of course there are literally hundreds of supplements and protocols that can be developed based on specific optimization strategies, and even based on my principles that I gave you guys. So the supplement level gets really deep, but and it's also very time consuming in ways, because you have to optimize and make sure that the supplements that you're choosing have their certificate of analysis. Do they actually have what they claim to have in there, right? Because like a lot of doctors and things will tell you, "Oh, don't take supplements, they're a bunch of BS," and but then you tell the doctor and you're like, "Okay, but for your patients that have vitamin D deficiency, what do? You recommend them vitamin D supplements." And so supplements do work. It's just about the efficacy, the bioavailability, the quality, etc. So supplements are one level. Then the next level is going to be devices. So we're looking at rejuvenation devices and how those devices may operate to do whatever type of thing that you're wanting. If it's usually those are aesthetic, and then some are a little deeper than skin deep, but they don't go too much far, like with near infrared technology, right? That's red light therapy and stuff like that. But so the next is devices, and then the third is looking at your regenerative medicine therapies and tailoring specific plans on that. Now, that can go very many levels deep, and you also would want to utilize my strategy with the regenerate strategy, right? You would need to do that, but with the regenerative therapies. But in between that, we can also like a health coach or consultant like me we would go in, and we would also be able to. We should be competent enough, ideally, to go and look at what doctors and specialists they need to go to, help guide the clients to go to those doctors and what to say to them, and to make their time with those doctors and specialists as efficient as possible. That's essential. Because, being that my dad's a doctor, I mean, I know really well, I know both sides of the story. I've heard it over and over and over again from a doctor and other doctors. do. And patients, plenty of patients talking about their both sides having qualms with each other, not truly understanding each other. And there's a lot of issues there that patients and doctors have this communication barrier, and a lot of it is due to a time barrier. And so health coaching in general is something I want to see more of in the future. I hope that this talk also inspires other people who are competent and capable, like me, to go and be a health coach, because you can significantly improve someone's health who does not have a background in medicine, who doesn't have a background in biotechnology, who doesn't have a background in anything like this, and at least help them get through things a lot more easily. Now, AI can help them too, but it's nuanced and AI is wrong sometimes. Especially when it comes to the more complex things, it can be, have some little inaccuracies that can make a big difference. So, ideally you want to get an expert or a specialist, or, just someone who's competent in this area to help you further refine this. And basically, yeah, that's kind of what I offer is these services. So I will make these tailored plans based on their budget and based on what level of depth they can do on each side, and also look at testing and new testing and affordable testing and ways to get that testing, and help them analyze it, and hopefully bring them all the way to the regenerative therapies, and very, very carefully approach that. And to make roadmaps for them, even in the regenerative therapy side, which is, I'm very excited to get to that with my consulting right now.
Yes, thank you very much for that overview of your services, and I can see how a lot of people would find that to be a very valuable approach, particularly because of the attention provided and the information provided to them, which would enable their interactions with the medical system to be a lot more efficient and impactful. Now, I'm wondering also, based on what you know to be optimal health habits, do you know of any people today who do behave optimally given the amount of medical knowledge and technology that is accessible to us right now, from the standpoint of lengthening their lifespans? Is there anybody who's doing the absolute best that they can? And if it's a public figure, feel free to name that public figure. Otherwise, you can anonymize that person, but just say that you know of this kind of individual who is doing their best.
Yes. So I think the person that of course comes to mind to me is Brian Johnson. But there's also another lady whose name I forgot right now, who she is actually was at the top of the longevity charts as well. And she's, a mother, and she doesn't do anything super special, but she has very similar results to Brian Johnson. So I think those two examples, are pretty good examples. If you look at the longevity Olympics in general, though, and you'll find her name. I feel bad that I forgot her name, but there's if you look at the longevity Olympics, I really think for anybody listening here, look that up, longevity Olympics. You will find the names of the people who are ranking at the very top of that chart, and I think that those people are, for what we have with the tests right now, which there's a lot of debate on the accuracy of the tests, and I don't know enough to speak on that, but from what we have right now, I think that Brian Johnson and everybody at the top of those charts, we really got to be looking at those protocols. And I did analyze one of those gentlemen a while back as well, and I was like, oh, this is very similar to my supplement regimen. I was like, oh, that's so great. I was like, this is pretty much like all the stuff I take, but I have more maybe. But he was like, just listing his top ones, so I don't know what else he might have taken. But anyway, we can definitely, I definitely recommend anybody follow Brian Johnson. I think that it's great that he has, all the resources at his disposal to tackle this problem. He's a benevolent type, a philanthropic, millionaire, billionaire, whatever. and those definitely do exist, and Brian Johnson's one of them, and he's doing a great job with, really helping to move the field of longevity forward in terms of being somebody who's willing to experiment with himself and test these therapies on himself, and then also further refine the protocols and really look very hard at the, supplements that he's taking and, things like that. And I can totally see, if I were in his shoes, I would probably create my own, supplement brand or whatever too, or products, because you just, more, you just know, like, okay, this is, I want to be able to see the quality and be at the beginning stage of the quality control and everything, and really ensure that what I'm getting is what I'm paying for. So it also makes sense that he's even developing new stuff too. It's kind of a natural process. And I personally would love to get in touch with Brian Johnson. I haven't tried yet, but I'd love to get in touch with Brian Johnson and be part of his team of people that helps him optimize his protocols as well. Like, I really think he should be taking spermidine at night, not in the morning. Like, I remember I saw that in one of his videos, and I was like, well, what? That doesn't make any sense. He should take it right before bed because it helps improve the process of autophagy. But there's always things to be learned, and even a whole team of people can miss something, and like that is maybe somewhat important, like that, like the time when to take a supplement, ideally, or there's always things that could be improved on. And that's what I like about Brian Johnson, is that he has the resources and the benevolent kind of will to try and tackle this stuff and help others understand and develop things around it. And yeah, so that's my answer.
Yes, well, thank you for that response, and for anybody who is interested in the people who have been tested according to the metrics used by Brian Johnson, look up rejuvenationolympics.com. And I did have a approximately 2.5-minute interaction with Brian Johnson at Longevity Summit Dublin in 2023. He presented remotely because he doesn't like to travel by more than 2 time zones from his home in the Los Angeles area. And I talked to him more about, let's say, the cultural realm and how to get more people to embrace the don't die ethos. But it was an interesting interaction, and it's available from the Longevity Summit Dublin YouTube channel. I also did notice that Brian Johnson is selling his own blueprint line of products, and that includes essentially ready-made meals. So do you think if somebody of fairly ordinary means were to subscribe to his meal plan, that would be a significant improvement over a conventional American diet? Again, I'm not talking about eating hamburgers every day. I'm talking about the way most Americans who are somewhat conscientious about their health would eat.
I'm really glad you asked that question, because actually Brian Johnson says that one of the things that he has specifically chosen out of his protocol is his choice to have a vegetarian diet rather than going purely by the science. And I hope, this is there are many things I've had to talk about, and when it comes to science, I'm just like, oh no, like, it's gonna upset people, but like, these are facts, this is reality, and like, I'm optimally truth seeking, like, as an individual. It's part of my core morals is to be truth seeking, and the truth is that we're omnivores, and like, if you break down systemically the bioavailability of nutrients of both plant-based and animal-based diets, you'll see that there is no complete diet without having both. And maybe someone would be healthier for a time on his diet, especially compared to the typical American diet, and it would probably definitely lower the potential of heart disease and stroke and anything that's related to bad cholesterol. But if you want the most bioavailable forms of vitamins and nutrients, you must have a diet that includes both bioavailable nutrients that are more highly bioavailable from animal proteins and animal sources, and you want vegetables and other things as well, nuts, everything, legumes, because there are more bioavailable forms of those vitamins in certain types of vegetables and etc. as well. So it's when I'm looking at supplements even still as well, one of the main factors I'm looking at is bioavailability. And there are different forms of vitamin C and different forms of iron. And the more bioavailable form of iron is in animals. The more bioavailable form of vitamin C is in plants. So, like that's just truth. That's just truth, people. We are omnivores, and we're omnivores for a reason. So this whole carnivore versus vegetarian or vegan, I mean, it's honestly it's just a little ridiculous. But I mean, I'm not shaming anybody who chooses one or the other. It's just, but if we're looking at the science, and you can literally go on ChatGPT right now and put it in most bioavailable forms of nutrients on both of those two sides of the, same coin, and you'll realize that true. So.
Mhm. Yes, thank you for that answer. And it's interesting, based on feedback from our viewers, many of them agree with you. I myself am an omnivore, and I don't really have any prohibited foods as such. I will not eat animal organs, and I will not eat exotic species of animals. I also will not eat babies, but that is more of a moral kind of consideration, like no veal, for instance. But I will eat cows, chickens, pigs, etc. And one major reason for that is because I'm a runner, and this is a ready source of protein, and I would be concerned if I didn't have that source unless I really optimize some sort of plant-based diet to provide the same kind of nutrition. Art Ramon says no vegetarian for me, and Zach Varkaris in our chat also agrees with you. And it does seem that a lot of people who are vegetarians do so for ethical reasons as well, though there are people like Dr. Michael Greger, for instance, who advocate a plant-based diet. And I'm not really going to opine on whether that's superior to an omnivorous diet, but I will say it would be difficult for me not to be omnivorous given my exercise regimen in particular, and the fact that I run about 40 miles per week. But our friend Zach Varkaris also has a question for you. He wonders, how do you advise people to avoid microplastics and other pollutants in the environment when we are surrounded by them in our water, fabric, soil, etc.? So it may not just be a matter of figuring out which foods might not have them. They seem to be everywhere.
That's another great question. That is one that gets so detailed, even with my personal protocols, to avoid microplastics and other contaminants. But some examples would be, first is your water and your food sources. Try to get those as pure as possible. So I do have a really advanced reverse osmosis system that also remineralizes at home. I spent almost $1,000 on that system. Now I was an early adopter though, so they've gone down to about $300. And they're by a company called Water Drop, and highly recommend those guys. And I can, anyone that messages me, I will link you the options as well. And then for food, of course, I really think that's going to have to come down to advanced agricultural systems. And the best way to reduce some of those contaminants, still like pesticides and other things, maybe not always microplastics or forever chemicals, because most food is still, whether it's grown outdoors or indoors, it's getting exposed to microplastics through hydroponic systems, which ultimately the PVC breaks down and releases all sorts of bad stuff. So I do not recommend hydroponic systems, actually. I recommend regeneratively grown, ideally, food. So if you guys have ever seen or understand anything about like regenerative soil science, regeneratively grown foods are a step further from or above, organically grown food. And that will help reduce a lot of the contaminants, or organic is fine too, but at least that will at least help reduce a lot of the contaminants that are related to like chemical inputs like pesticides, etc. And then of course, like, even in one of Brian Johnson's videos I saw recently, he was saying, look, we're going to have to manufacture our own macadamia nut milk. And I'm like, I get that, because the lining of all things that look like they are paper are actually plastic. Aluminum lining is actually, like, there's lining on aluminum cans, unfortunately. So even if you get canned beans or whatever, there's microplastics in that. Unfortunately, it's such a tragedy. A lot of things come in plastic. Really, I think that's going to be the consumer messaging those companies, saying, I have bought X $100 amount of your product. I really would appreciate if you guys switch to glass, or how can you please switch to glass? Like, it's going to have to be the consumer asking for that. And then also, with chicken is like a huge issue with the microplastic contamination, even if you get organic chicken, because of the I forget what the specific chemical name is. I'm usually pretty good at those types of names, but I forget the chemical name for the type of liner that they use to collect for the chickens. That is there's no way to wash off the microplastics from that. So the only way I eat chicken these days is I get a whole organic chicken, and though that's covered in plastic, you don't have to eat the skin. So I take off the skin, I remove the skin after baking the whole chicken, and that's how I'm able to eat chicken, for instance, because otherwise chicken is going to be full of microplastics.
So in essence, do you think that if something in your food or water is touching plastic, there's a risk of the microplastic seeping into it? Like if you drink water from a plastic water bottle, or if you microwave something with a plastic wrap on top of it, is there a danger of getting microplastic contamination, or does it depend on the type of plastic or the type of process that you use?
Yeah, anything that touches my plastic is basically at risk because of shearing, and then also through not diffusion, just it leaching into that phthalates and things leaching into those chemicals, leaching into the food or whatever it is that it touches. But so I just watched a really interesting thing with a toxicologist not long ago. And she was talking about the shearing. So every time, if you are drinking from a plastic water bottle, please don't drink from one if you can. At all means, avoid it like the plague. But if you absolutely no other choice to drink from a plastic water bottle, it's probably got lots of microplastics, not just microplastics, but nanoplastics. And so it gets into the nano level, and it gets into the cell walls, and it gets trapped there, and you have to rely on your cells processes to remove that waste, but it's not guaranteed. And there are endocrine disruptors on top of it. But if you hold the plastic ball and you squeeze it, there's something that's called shearing. And so the plastic shears at the micro and nano level off into your water. So everyone's done it at some point. They're like, oh, I'm going to like crinkle up my, plastic water bottle because it sounds nice, or it just, it's just a little like tick that you're doing at that moment because, whatever. And it's not good.
Yes, well, that is definitely a matter of concern, and it's very difficult to avoid, especially because there isn't really a good substitute for plastic bottles. For instance, as a runner, if I want a source of water with me on my run, I'm not going to carry a glass bottle with me. That would be inconvenient in a variety of respects. And
yeah, and those packs, right, are also plastic. I've thought about this a lot, and someone needs to develop basically a stainless steel kind of like square can, or even like ergonomic can or something that you can put on your back. That would be best, because it throws off your center of gravity, even you know, carrying a bottle or whatever, but or carrying a metal stainless steel bottle and stuff. But something that's like a metal pack, stainless steel pack, would make the most sense. But then even that there's usually have a plastic straw attached to that. So basically something that could fit in a backpack that you could take out and then drink. You know, it's yeah, it's very difficult.
indeed. And our friend Zach Varkaris also shared this article from Consumer Reports about findings of widespread presence of plastics in food. And he mentioned that the Wendy's chicken nuggets have plastic levels that are off the charts, apparently. So, well, thankfully I haven't been eating those. So at least that's one saving grace. But anyway, we have so many questions from our viewers right now, and I will try to go through as many of them as possible. First of all, Alan Crawley notes that he likes the analogy of or equation of biology being nanotechnology, and he would like a bit more elaboration on that. And along with that, he wonders, at what point is something carbon-based? Like, there are a lot of substances that have carbon in them, but when you speak of something being carbon-based, what are you referring to?
I guess I'll answer backwards. So carbon-based, like carbon-based life forms, and basically the when it comes to you know, biology, basically being nanotechnology, or us being, you know, biomechanical machines and things like that. I was more getting into, you know, the fact that drugs are like nanotech as well, or they can be looked at in that way. And now, though none of us really like that word, like even me, I don't really like that word, the word of a drug, right? But we really have to start seeing drugs as that, because if they can do have similar results to a gene therapy when it comes to like extending telomeres, we really have to take drugs and drug discovery more seriously, and the safety of that as well. And that's super important, and that's something that I want to segue into with another talk, maybe in depth on bioidenticals, bioidentical molecules, precursors, and analogs. And I actually have a scientific paper that I'm looking for co-authors in right now on that very topic. It's called "The Case for Precursors and Bioidenticals Over Analogs." And you know, in that paper, I go into, you know, how you know, like basically herbs and certain drugs that have already been created, synthetic drugs and stuff, all those things are analogs, actually. And what analogs are, and what the difference between an analog is and something that is bioidentical, so something that's exactly the same as what's produced in your body, versus something that is the molecular structure is slightly off, which is like something from plants, right? Because plants are eukaryotes and we're eukaryotic organisms as well, but you know, we have diverged on the evolutionary tree, and we are, you know, the plants produce, for that reason, plants produce something very similar to what we produce in terms of molecules, but they don't produce the exact bioidentical of what our cells produce, right? Because we're related, but we're not the same. And so even herbal supplements are an analog, and thus there is a need in drug discovery for us to find bioidentical versions of herbs that work pretty well for certain things, so that we can, and the precursors to those, which means the molecules that make and build the bioidentical version that we make and build in our own cells, so that we can give the building blocks of those bioidentical molecules to our body so that we can produce more of something. And basically, when it comes to like my supplement that's based on those same principles, my supplement regimen and roadmaps that I give to my clients, we can sometimes, depending on what it is, we'll recommend the precursor, and I'll recommend the bioidentical version, and I will have them supplement cycle those two things, so that basically as you age, you're losing the ability to create the same amount of a molecule that you would when you were younger, the bioidentical version. So you have to supplement some of that, of the full bioidentical molecule. But you also don't want your body to get dependent on that. Basically, your machines, your molecular machines, and your genes and your genetic expression to get used to that and cause genetic downregulation, so that you don't produce as much when you're taking something externally, and the body gets used to it, and it's saying, oh, okay, don't produce as much anymore. We are mechanical factories on the inside. I mean, I love manufacturing and mechanical engineering. My grandfather was a mechanical engineer, and you know, I I love manufacturing techniques. I look at the body in the same way that somebody who is into mechanical engineering would, for a lot of the time, that reason. But we are self-repairing machines, and that's what I really wanted to emphasize, like, even more in my talk earlier, was that we repair ourselves, and that is essential. Like, we need to be tapping into that, not just in a like mind over matter way, because that's only 30%, up to 30% of the placebo effect is actually physical reality, right? After that, we have to use physical things, because we're also physical beings, right? So that's what I have to try to explain to people who are all about the mind over matter stuff. It's like, it's true, you're 100% right, but we only get 30% there with that strategy, maximum, with mind over matter, because it's the placebo effect is only that effective, and maybe it's 100% effective for one thing, and you were able to mind over matter something, right? And you were successful. But if we want to get beyond the Hayflick limit, if we want to get into radical life extension, if we want to extremely optimize our health span as well, we have to do physical means of therapies. And I know you guys aren't the audience I'm talking here to here. I'm talking to another audience, but like, we have to do physical things to get us all the way to 100% optimized health.
Yes, indeed. Thank you for that answer. And yes, I think the vast majority of us are the kind of audience who does tend to favor physical approaches over mind over matter kinds of approaches, though there is a certain element where one's thinking can help, especially in terms of motivation or pushing through difficulties. If pushing through difficulties is part of the solution for a problem. For example, when I had long COVID, I ultimately resolved it through a graded exercise regimen, but I needed to have the mindset that even though it might not feel like it at the moment, doing what I'm doing consistently is going to lead toward a resolution. But yes, for the vast majority of health conditions, and especially for greatly lengthening lifespans, a predominantly physical approach is going to be needed. And along these lines, a key question that I have for you pertains to whether you think it is possible for most people to reach longevity, escape velocity in our lifetimes. And if so, approximately when do you think it would be possible? And could people in our generation or older generations live long enough to live forever, in the words of Terry Grossman and Ray Kurzweil. Now, Ray Kurzweil, I believe, is 76, if not 77 at present, and he thinks he can live long enough to live forever. What do you think about that? And also, what do you think about people who are younger, people who are in their 50s or people who are in their 30s today?
So the future is in our hands. And in terms of, if we follow those principles that I laid out, and if we can, as a society, or at least just enough of us in the right realms, reach an understanding on this, a conceptual understanding and a philosophical understanding of this, and we can expedite regulatory hurdles and utilize these principles to create tailored regimens and protocols that would take people all the way to radical life extension. I think if we really wanted to, we could develop a functional protocol that achieves radical life extension within the next 10 years, maybe even 5 years, especially with AI and AI drug discovery. Okay, but there are really significant hurdles when it comes to exponential growth, and that is the human element. Technology can operate on an exponential curve, but humans operate on a linear curve, on a line. We don't operate on an exponential curve. So humans are the main human understanding and general acceptance and comprehension of this subject is the number one barrier. If we can overcome that barrier together, and then regulatory hurdles will fall away. All the other hurdles will fall away if us as scientists can get on board with a systematic approach to how to create protocols for aging, then and create radical life extension as a possibility, then anything is possible. That's my true belief. I really feel it is just the comprehension. A lot of it is comprehension. That's what it comes down to.
Yes, thank you. That is an excellent answer. And I agree, it does depend on us. It depends on us being able to change the culture and motivate enough people to support the acceleration of development of longevity protocols that can truly reverse aging and usher in the era of longevity escape velocity. That is also the mission of the U.S. Transhumanist Party, why we are so focused on politics and culture and influencing public opinion. So thank you very much for that. And now I will ask Art Ramon if he has any questions.
Yeah, as far as mitochondrial therapies, I hear there's developments, breakthroughs possibly. I think that might be one of the issues that I deal with long COVID is some sort of mitochondrial dysfunction. How far are these mitochondrial therapies away? What's your knowledge of that?
So actually, Art, I have a protocol specifically for mitochondria, and it's using my principles. And what it does is it looks at supplement avenues to tackle the systematic removal, repair, and replace, and repairing and replacing old mitochondria. So I think you could, develop that yourself even, or reach out to me and we can talk about it. But, if for anybody listening who, they're like, I can't afford Kira's services, or whatever, or they're concerned about that, if you follow these principles, there are ways to increase mitochondrial biogenesis through a supplement regimen even. And some of these other techniques, like the young team that I was able to speak with, that they had gotten to the very top of a biotechnology competition. They said that for people who are suffering with heart attacks, post-heart attack, they were able to develop an mRNA technology that was able to deliver the information to the heart that would tell the heart cells to and those muscle cells specifically to increase the mitochondrial biogenesis in the heart, because after a heart attack you lose a certain percentage. I don't know how much it is, but I think it's like a lot. Like you can lose I think up to like 30-50%. Don't quote me on that, but you can lose a lot of your mitochondria and your mitochondrial function after a heart attack, because the oxygen in those tissues gets goes significantly down during a heart attack, of course, and you lose a lot of oxygen to those mitochondria, and the mitochondria will die. So you have to regenerate that mitochondria, and if you look into supplement regimens and other ways following my protocol, then you can I really believe you can make a lot more mitochondria, and there's other ways to do it too. There's through exercise and things like that, but I really think that you really have to stimulate the regeneration of mitochondria as well.
And I've sort of done that. I've been able to get to a point where I've improved, and through very graduated exercise. But it seems like if I take a tiny break, it's like not exercising for 6 months. So it's like, how could I quickly lose the progress of graduated exercise? It's like these bad mitochondria are sticking around even longer than the better mitochondria. And
Yep.
So how do you get rid of these bad mitochondria if they're even tougher at surviving than the more efficient mitochondria?
So yeah, that's so true, Art. So there is there are some other therapies, mitochondrial therapies in particular, that are coming out that I've heard about, and I don't know if they're out yet, or if you might even know more than me at this point, since you've been looking into that specifically. But those are going to be probably more expensive and prohibitive to most people. So that's what I'm saying. If you look at or just you look at, let's try to remove that mitochondria first through supplements that help induce mitochondrial apoptosis, which there are supplements out there that do that, or that can hypothetically do that. So we'll have to talk more about that if you're going to reach out to me. Okay. We can, yeah.
Okay, so the key is that apoptosis part. That's probably what I'm missing. So okay.
The removal, yeah.
Yeah, the removal. Okay. Thank you.
Yeah. You're welcome.
Right. Thank you very much, Kira. And we do have a follow-up on this topic from Zach Varkaris. How do you measure the efficacy or improvement of the mitochondrial function from your protocols?
Well, I haven't had the opportunity to work with somebody on that yet. So it just depends. So one thing I wanted to tell you guys is that if you reach out to me about any services and you were able to hire me with these services, you are going to be contributing to my longevity handbook that I started writing back in 2019. And it actually started out as a longevity supplement handbook, and it just ended up evolving into, I was like, this is basically a radical life extension handbook. Maybe that's what I'll end up calling it. I still haven't figured out what the exact title of the book is going to be, but it just grew and grew and grew, that document, and kind of just looking at the body from first principles, and okay, you guys are about to conclude, but I wanted to say one last thing, is that everybody needs to learn how to think from first principles. If you can think from first principles on anything, you can solve any problem. I assure you, you can, because looking at something from what are the foundations of something, let's boil it down. And you know, Brian Johnson likes to talk about zero earth principles, and I agree with that too. I think that's a great idea too. But the more commonly known one is first principles. If you're looking at the body from what is the body made out of, what are the foundational elements, minerals, trace minerals, proteins, etc. And testing. Oh my God, I didn't even get to multiomics, guys. I wanted to talk about multiomics too. But that's one to look up as well. So basically sequencing all your omes, not just your full genome, but your proteome, your mitochondrial genomes, your your epigenome, everything. Yeah.
Yes, well, thank you for that response, and we should definitely have you on as a guest again to delve into this, as well as the other areas that you mentioned that we just didn't have time for today. I do think we can fit in one more question in the 2.5 minutes that we have remaining. This one is from Josh Universe. He wonders, what are your thoughts on cryonics, and do you think it will still be a viable Plan B option in a longevity portfolio?
Oh my gosh, that was the last thing I wanted to mention. I didn't even get to mention at all was cryonics. Yes, I want to do a whole talk on that sometime, in depth on the process of. I know it's a morbid topic, but on the process of dying and reversing that process. And it's a lot more complicated and interesting and nuanced than people think. I am a cryonics policy holder, and I still believe in cryonics. I think it's a really great Plan B. I think everybody should have a cryonics policy. That's how I truly feel, because even if we were to achieve radical life extension, you do not want to miss out on the boat of being able to be revived as well. And once people understand that death is a very actually slow mechanical process, again, looking at us as machines and how those are all just biomechanical processes, electrical processes even, and really truly understanding that from that kind of first principles level of what we are, people will see that cryonics is not a sham. Cryonics is a real Plan B. Yeah.
Yes, thank you very much for that answer. And of course, we have hosted many virtual Enlightenment salons with distinguished cryonicists, and we will continue to do that to inform people of this Plan B and hopefully catalyze some advancements in both the technology and people's uptake of it. Daniel Tweed, our 2024 vice presidential candidate, writes cryonics should be no more controversial than induced medical comas. And he also has a compliment for you, Kira, such a knowledgeable guest. Thank you very much for joining us today. I think we learned an immense amount about where, let's say, the cutting edge of healthy lifestyle practices, as well as what is available for people who are determined to lengthen their lifespans and health spans would be. And I really wish you all the best in your personalized longevity consulting practice. I hope you do get to write that handbook and share the insights that you gain from interacting with people of a wide range of attributes and life situations. And we definitely want to have you on as a guest to discuss all the topics we couldn't get to today. For now, I hope that we can all live long and prosper.